Okay, in 32.8, okay, we're talking about the advanced level, how to identify anode and cathode. Previously, we mainly used one method, which is CAN, but in some of the questions, they may not provide you the polarity of the chemical cell. So we're going to talk about this in this video. So level 1, okay, like what we've mentioned before, okay, we're using CAN and CACA. So this one is so typical. We know that this one is anode, cathode, okay, and then we know that this is anode and cathode. Okay, so by CAN, chemical cell, anode negative, and then alternatively CACA will do. So this one is a very basic one. Most of the question is in level 1. Some of them will be level 2 by flow of electrons and current. Okay, you can see that right here. Okay, they won't tell you that, okay, the polarity of the battery. So they simply say DC supply, but they will give you another information, which is electron flow direction or current flow direction. Okay, so you have to pay attention to this one. Okay, it's pretty simple. What you need to know that, okay, electron flow, when the electron come to here, okay, they will attract certain kind of ion. The ion, because this electron is negative, so the ion attract towards it, okay, have to be cation. Okay, so you'll find that they will be like metal cation. Okay, for example, some of them may be Ag plus or maybe H plus or things like that. So therefore, electron flow, okay, get to here, okay, they will attract cation. As that electrode is attracting cation, so therefore normally that one will be cathode. Okay, so you'll find that, okay, if this one is cathode, then by ACAC, okay, then you will know that this one will be anode, and this one will be cathode, and this one will be anode. So for this one, okay, is a DC supply anode, then it have to be negative, and this one will be positive by using CAN. Okay, so it will be like that. So sometimes, okay, we are using current. Okay, the question they will show current. Okay, you just have to know that current, okay, and electron flow, they are not the same. Okay, they are reversed to each other. Okay, so when you see that, okay, we got a current. Okay, first of all, you use a reverse arrow to represent the electron flow will be all right. So the reverse arrow, you know that electron flow. So when electron come here, the cation will then move forward. So therefore, we will know that this one is cathode, anode, cathode, and anode. So right before the current flow, remember, when you're giving current flow, you convert it to electron flow first. When you got current flow, convert to electron flow. Okay, and then you will know that which one is a cathode, and then by ACAC. So this one is level 2. Okay, when you see that electron flow and current flow given to you, then you can identify the cathode and anode. Level 3 is more common to be seen in the public exam. Okay, so for level 3, okay, they won't give you the polarity of the battery. Instead, they will tell you what product form at the electrode. So that you base on this product form, then you're going to predict, okay, what kind of product you're going to have. So let's have a look at the first examples. So you can see that from this one, okay, the battery, it doesn't show polarity, but you can find that, okay, we got some electrodes here, some electrolyte here. Okay, in the questions, normally the first statement, they will say, on complete circuit, the mass of electrode B increase. So this one is a statement that we have to pay attention to. Mass of B increase. So what do we have in the electrolyte? Okay, so in the electrolyte, you got Cu2 plus, H plus, SO42 minus, and OH minus. Okay, based on the concepts, okay, preferential discharge due to the position ECS, we found that Cu2 plus and H plus. Cu2 plus has a lower position than H plus, so therefore it will prevent discharge. So the discharge one, it will be the Cu2 plus. Okay, so it said that mass of electrode B increase, so you anticipate this one will be the cathode forming. Okay, so mass increase because copper deposit. So therefore, based on this, you know that, okay, copper, before forming copper, it must be cation, right? So therefore, that one will be cathode. Okay, So after knowing this one is cathode, then we can know Ca, Ca, Ca. Okay, so this is what we're doing. So the other one examples that you can see on the right hand side, okay, we got colorless gas given off from electrode B. Okay, colorless gas given off electrode B. So again, you can see this one. Okay, we are having copper 2 sulfate, copper 2 sulfate solution. So copper 2 sulfate solutions again. Okay, we'll find that the Cu2 plus, H plus, SO4 2 minus, and OH minus. The discharged one should be Cu2 plus and OH minus. So at B, when you see bubbles coming out, you know that these bubbles, okay, should be talking about O2. And O2, before it become O2, is talking about anion getting there. So by doing this, we know that the electrode should be anode, cathode, anode, cathode. Oh, it will be like that. Okay, so based on the product form, we can predict the ion discharged. Based on the ion discharge, we can know the type of the electrode. Okay, so give you some more examples. Okay, what we have. Sometimes they may say things like this. Okay, for example, colorless gas, we like glowing speed. So what should it be? Okay, it should be O2, because O2, okay, they are coming from OH minus. So therefore, this one should be anode. Okay, and then if it is colorless gas, which can give a pop sound on burning speed, so that one should be hydrogen. Okay, coming from H plus, because this is positive. So therefore, because it's a cation, so that one should be cathode. Okay, and then if it is a reddish brown solid form, reddish brown solid, okay, we know that we're referring to copper. So beforehand, it should be Cu2 plus. That one should be cathode. Silvery solid, okay, maybe silver, maybe other kind of metal. But anyway, okay, they have to be cation, right? So in this case, we know that that will be cathode. So we got some brown, greenish yellow, violet vapor. So all these things, okay, you must know that they are referring to like bromine, chlorine, or iodine. So all these things must be coming from bromide, chloride, and iodide. So in this case, it will be anode. Okay, lastly, okay, it's talking about the mass of the electrode. When the mass of the electrode increase or decrease, it can be either, okay, forming some, normally the mass increase is talking about some solid form on the surface. For solid form on the surface, normally referring to the metal. Okay, you can think about, okay, there is no metal, it will forming some solid on it. So therefore, when the mass increase, normally referring to some metal, so metal must be from a cation. When the mass decrease, you must think about like the metal, okay, become an ion. Okay, so for the first case of a metal being cation, it have to be cathode. While the other case, you just learn one. That would be like copper as anode. So in that case, then it will be anode instead. Okay, so these are some summary, okay, of some common seen chemicals, okay, on different part. Okay, so you can have a look of it. So give you one more example, a few more examples, okay, very quickly. So silver deposit at carbon electrode B. Okay, so you know that silver must be from cation. So electrode B will be cathode, anode, cathode, anode. Okay, while the other one, copper electrode B dissolves. Copper, and it will dissolve. That must be anode, because Cu becomes Cu2 plus, okay, and losing electrons. Okay, so this one is a reduction. Sorry, it's an oxidation. So therefore, this one must be anode. Okay, so electrode B is anode, then cathode, anode, cathode, anode, and cathode. Okay. So last one, okay, just want you to have a look at this, okay. So when we talk about impure copper electrode, pure copper electrode, okay, this one long ago it will be in the syllabus right now, but right now, okay, it will have been deleted from it, okay, too many things to study. So this one is called copper refining, okay. So what we want to have is we want to have the pure copper increase in mass, the pure one getting more and more, while the impure one, okay, they will decrease in mass. Okay, so if in this examples, okay, we know that the pure one we want to increase in mass. When I want it to be increased in mass, okay, the copper 2 plus I have to get it there. So in this case, this should be cathode, this should be anode, cathode and anode. So this will be the negative one, and this will be the positive one. Okay, get it? So more or less it will be like that. Okay. So conclusion, there are 3 ways to identify the cathode anode. So the first one, typical CAN, CACA. Second one, for the flow of electrons. Okay, remember when you have current, convert it to electron flow first. Okay, and then you know that the electron attracts cation. So that one will be cathode. And then you can think about like CACA. Okay, and then third one, products format cathode anode. So when you see the products, okay, you think about the ion preferentially discharged, and based on the type of it, the type of the ions, okay, see whether they are cation, or cation or anion. Then you can identify if it's cation, then that have to be cathode. If it's anion, then it have to be anode. Okay, so basically, okay, this can help you to identify which one is cathode and anode, and then you can write the corresponding half equation for that. Okay, so that's all for this video. Bye bye.